Dark matter is a mysterious, invisible form of matter that is thought to make up about 27% of the known universe, outweighing visible matter about 6 to 1. Still, despite making up a considerable chunk of the universe, it has eluded our understanding since its existence was first suggested in 1933 by Fritz Zwicky, a Swiss-American astronomer. To date, dark matter has never been directly detected. However, scientists believe that by measuring the effects it has on its surroundings, Webb could answer some major questions about dark matter. This in turn would greatly advance our knowledge of the universe at large. Hey everyone, welcome to Space Scientists. In today's video, we are going to talk about how James Webb is going to make a terrifying discovery about dark matter. So if you want to know more about it, then stay with us until the end of the video. And before we start the video, don't forget to like this video, subscribe to our channel, and ring the bell icon for more amazing videos. Now that James Webb Space Telescope is safely in space and nearly fully deployed, it's worth taking a look at some of the cosmic mysteries astronomers hope to unlock with NASA's new flagship observatory. Among a list of high-priority targets, it will integrate one of the most enigmatic puzzles facing astronomy and cosmology today, as it may well provide insights into some of the most esoteric questions in cosmology, helping to better characterize the nature of dark matter and dark energy. Now, before we talk about dark matter, let's talk about black holes. Talking about black holes are thought of as massive, distant, and scary objects in space, which are the remnants of dying stars. These dark remnants have the gravitational pull so strong that if you were to get close enough, you will see that even light will bend to its will. Scientists and researchers have found various different big and medium-sized black holes, including the supermassive monster at the heart of the galaxy, which has also presented a long-standing mystery in astrophysics called the unicorn black hole. When you observe dark matter, you have to sort of always go in a roundabout way because you can't see it. But Webb does have the capability to try and get at that in new, orthogonal ways, looking at the dynamics of galaxies. Klaus Pontoppidan, a project scientist at the Space Telescope Science Institute, said in a news conference recently, for example, as a roundabout method of detecting dark matter, astronomers can use existing technologies to measure how much mass is in a star and galaxies. Some of the main evidence for the existence of dark matter is that many galaxies could not exist and move as they do without a large amount of invisible mass. To help astronomers more precisely locate that dark matter, Webb will take extremely sharp images in which researchers will be able to observe disturbances caused by gravitational lensing, pointing them to where the invisible mass is lurking. Studying black holes and neutron stars is extremely crucial for scientists, since it tells them about the ways stars form and die. However, finding black holes is extremely difficult as the individual black holes don't emit the same energy rays that other objects emit in space. Most known black holes were discovered because they interacted with the companion star, which created a lot of X-rays, and those X-rays are visible to astronomers. Now, what is dark matter, and how is it related to these monstrous black holes? Dark matter makes up over 80% of all the matter in the universe, but it doesn't directly interact with light in any way. It just floats around, being massive, affecting the gravity within the galaxies. Dark matter, which has never been directly observed, is thought to be the most of the matter in the universe and act as the scaffolding upon which galaxies form and develop. On the other hand, black holes, which can be found at the centers of most galaxies, are also believed to be made up of dark matter. In imaging distant galaxies, Webb can find these masses and determine what's missing or not observable, which would then likely be dark matter. Webb will be particularly well suited for this type of measurement because its very sharp images will allow very small disturbances to be measured, and because it can see so deep into space, giving it access to many more background galaxies to measure disturbances caused by this gravitational lensing effect. according to a NASA fact sheet about Webb. Also, Webb will observe many statistics of galaxy evolution. The fact sheet adds, and scientists can compare these observations to theories of the role that dark matter played in that process, leading to some understanding of the amount and nature of the dark matter in galaxies. Unfortunately, in the modern universe, black holes form only after massive stars die, then collapse under the weight of their own gravity. So, making black holes require many stars, which requires a bunch of normal matter. Scientists know how much normal matter is in the universe from calculations of the early universe, where the first hydrogen and helium formed. And there simply isn't enough normal matter to make all the dark matter astronomers have observed. That's where Hawking came in. In 1971, Stephen Hawking suggested that black holes formed in the chaotic environment of the earliest moments of the Big Bang. Their pockets of matter could spontaneously reach the densities needed to make black holes, folding the cosmos with them well before the first stars twinkled. Hawking suggested that these primordial black holes might be responsible for dark matter. While the idea was interesting, most astrophysicists focused instead on finding a new subatomic particle to explain dark matter. Later on, the idea was revived in 2015 when the Laser Interferometer Gravitational Wave Observatory found its first pair of colliding black holes. The two black holes were much larger than expected, and one way to explain their large mass was to say they formed in the early universe, not in the hearts of dying stars. So Webb is designed to see farther into space than we've ever seen before, which will also allow it to see farther back in time. By making these observations so deep into space, Webb will be able to study the early beginnings of the universe and its galaxies, and the role that dark matter may have played in their evolution. Scientists continue to work to understand when the universe's early galaxies formed, and the processes involved in this formation are driven by dark matter evolution models, putting different parameters on the first galaxies at different times. Therefore, scientists believe that Webb can be used to measure some of the basic parameters of those first galaxies in the universe and allow us to understand their luminosity, mass distribution, and much more. So scientists and researchers are very hopeful about how James Webb is going to unveil new secrets for them hidden in space, especially the secrets surrounding the mystery of dark matter and the relation to black holes. And this is it for today. What are your thoughts on today's video? Share your views with us in the comments below. Also, don't forget to give this video a thumbs up, subscribe to the channel, and ring the bell icon for more amazing videos about space. And thank you for watching.